Hello everyone. Today we will be presenting about our machine learning project, movie Curator. Our group is called Game and Friends. So we'll be using a recommendation system that's going to use content-based filtering. We got our data mostly from IMDb, but we also used web scrapers to find a synopsis of each movie. So these are the steps we used in our project. So first we cleaned our data, our IMDb data, and then we used web scraping to add plot synopsis. Then we pre-processed our model, and then we modeled it using k-means clustering. And then we predicted our model using cosine similarity matrix. And then finally we used an interface. So for cleaning our data, we removed unused columns and movies that had null values. The reason why we did so is because we believe that movies that have empty columns or null values are movies that most people wouldn't really watch. There are low budget movies, probably independent movies that most people have never really heard of and aren't really popular. And also one of our criteria is that we decided to include movies only after 1970 because then our data would be too big. Our movies are also mostly in English language, and runtime should be greater than 1 hour. And the movie should also be popular enough, having more than 1,000 votes. So for web scraping, we use Selenium and Firefox WebDriver library to create the synopsis. We created a function that would navigate the IMDb page and extract a synopsis. So you can see the code here. For model processing, we use term frequency inverse document frequency to extract keywords from the plot and synopsis. And we also counted the amount of keywords that we would get to identify what could be the most common themes of a movie. So here are the unique words we chose. So you can see that we use words like action, adventure, animation. These are the common themes that we got from the pre-processing. And now,
right, so next is our model. So we decided to use k-means clustering for our model. So the feature that we chose from the IMDb dataset that we are using after pre-processing is, first is the rating, of course, genre, production company, so which company the movie made, said movie, plot keywords, so we would have the plot from IMDb, and then we would pass it through a TI, I forgot what it's called, but it's pretty much like an NLP that would extract keywords that are common in other movie plots to be able to find similarities in the plot of the movies. And of course, plot is fairly small, but then we also have synopsis, which is a quite like a short summary of how the movie goes. So we also extract the keywords, and again, this is from the web scraping. Next is to encode our strings and string columns. So let's say the genre, the production company, those types, into numerical ones before we feed it into k-means clustering. So this is k-means clustering. Let me grab it. There you go. So this is k-means clustering. So before we would have sparse data, and we wouldn't know which part of like the cluster or like which group it belongs to. So that's what k-means clustering does, and is pretty much segment them into each group. So k-means clustering is an unsupervised machine learning algorithm, and again, it's used to group data, and it's fairly efficient and used quite commonly in a lot of movie algorithm recommendation systems such as Netflix, YouTube, and yeah, and of course, content based. So next. So here is our data that we have. So our IMDb data set has around 17,000 movies in total. That IMDb has around total 5 million actually. And again, a lot of them did get filtered out due to incomplete information. So here we ended up with around 17,000 worth of movies. And then you can see here the X is the midpoint of each cluster. And you can see here like there's a lot of like it's very mixed in between clusters. So in total here we chose in total of 10 clusters. Of course these can be more fine-tuned, but we found that 10 is a nice well-balanced one. And here's a snippet of how we extract the genre and the plot keywords and from the data set. And then this is the k-mean clustering code. So it's very simple. Python makes this very, very simple. As in, so we have 10 clusters that we mentioned before, and then the number of time. So these are all just parameters for the k-mean clustering. So let's talk about the predictions. So input and output. So for our program, we would like to have to input one movie title. So let's say if we put input Avatar, and the output should be you can select this 1 to 10 movies. So, and of course this will go through the k-mean algorithm, so it will find the one that best fit within the same cluster of the movie that are closest to the movie, for example Avatar. So the method that we use for the pre-processing for the model is we use cosine similarity. So it's cosine similarity matrix. So we used to find similarity between the movies, and for the two fields that we use was the keyword and the was it the plot keyword and the genres. And so next one. So here's an early example of the inputs and outputs. So at the very top left, we have the movie that we selected, which is The Avengers. So this one, it would say pretty much all the information about Avengers. So we have IMDb rating, genres, plot keywords. So team fight. In the future, we would like to add like possibly like a custom one like superheroes, but again, that's for the future. But you can see here that it actually recommended Avengers Age of Ultron. So this is a very similar movie that the viewer might find to be interesting. And so we've asked it to output around 10 movies. Of course, this can be fine-tuned, which we'll show later on. And these are all just extra information. So the other one that maybe we want to add for a feature would be best pictures or certificate. So certificates such as like R rating, PG-13. So depending on how mature you want the movie to be. And so here's the interface for the example interface. So we created this interface using Streamlit. And one wonderful thing about Streamlit is that it's all Python based, and they create a very responsive app. It shows genre rating, so all of this we've made it ourselves. And as you can see here, we have the number of recommendations, so we can limit them. This one we use 3, and we can also set range for IMDb ratings of how much how good you want the movie to be, right? So here we have Avatar, and then we have Zack Snyder, Justice League, Man of Steel, X-Men. So I'm going towards superhero movies a bit. Again, of course, we can do this a bit better. But if we move to the next page, so this is we switched it to number of recommendations to up to 10. IMDb rating, of course, we have our own range, and this is again Avatar. I'll show you a live demo later on. So this part I just want to add a little bit. So this is the web scraping part of the code. So first, we would check if there's like a partially scraped website. So if not, we just use the the filtered data frame that we got from the first processing, the #1 processing. So we will continue to work because there's a lot of movies. So I think it was 16,000 movies in total that we need to scrape from IMDb. So if I were to, so I'll just run all. So we'll load, check, then we initialize the WebDriver, and then it would start Firefox, and then here's the WebDriver that we have, and it will go through all the movies. So first of all, we've already gone through 0 to up to 12,138. Nope, never mind. 12,691 so far. So by the time that we submit this work, of course, this data would be done. But yeah. So right now you see that it would check. Okay, so the current movie, let's say Superman 3. Hey. Current synopsis is nothing, and then it would get it. So in the final scene, the lunch break, blah 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 blah, and then see that this is fairly fast, and you can see that it is still running in the background. So it would go through. So you see some of the movie synopses are not that great, but most popular movies usually have a very long synopsis that we can extract the keywords from. Right, and then after we're done, we would save it to a CSV right here, and if this is done, let's say halfway, we would reload it again. So it would keep going until it's done, finished. And then here are some of the example data. So we have the movie, let's say Wild Style, the greatest. So a lot of movies that we don't know, a lot of movies. And then you would have the synopsis here as an extra field. So we have also the plot here, which is like the smaller, shorter version. And then the synopsis would be the entire movie. So here we have the interface for our MLDL project. So we created this using Streamlit, and so dummy is going to be off. So let's give you a live demonstration. So here it is. So let's go for a movie that most of us is probably watched, but let's say let's go for the Avengers. So as you can see, as I type, it'll come up the Avengers, the first Avengers, Captain America. And so if we just enter the Avengers and then click that, and then we can choose the amount of recommendation. Default is 5, and IMDb rating, we don't really want to watch a movie that's below 6, I would say. So if we press recommend, it'll show us, okay, so this is the movie that you wanted to watch more, the Avengers, IMDb rating of 8, and then Earth Mightiest Heroes. So this is we used the plot for this one, but then also synopsis in the background to find similar movies. So we can see here, okay, so we have the Terminator, we have Spectral, which does look pretty similar, and X-Men Origins. So we can see like here is a bit more superhero theme. So if we go for another one, is Spider-Man. Ooh, okay, Spider-Man No Way Home. Actually, we'll go with Spider-Man 3. Go classic. And then here we have just a lot of superhero movies. So we have to have Shrek Into Darkness, which is not sure if that's close, but we have X-Men Apocalypse, Dawn of Justice, and here, like, if we have let's say 6.5, right? Let's see if this will actually work. If we have enough movies. Okay, we don't have enough movies, unfortunately, that are similar enough. So this is something that we do need to work on. So let's go with Tangled, because it's animation, and there tend to be a lot more movies that are animated. So if we see here, the minimum is 5.6, right? So let's say we decrease it. How about that? Okay, if we do decrease it, it does have the Popeye one, so the filtering does work. Let's say we go up to, let's say 6.1 to get rid of this one. Will that work? Yes, it would. Okay, so there's a lot of animated movies that are similar to this. You can see here, Tangled. And yeah, this is all very responsive, so even if we, let's say, move this a little bit, you can see that it changes accordingly. It's very dynamic. And yes, so this is our interface for demo. We'll also provide a link. So thank you. So this is our presentation for Game and Friends. So this is a movie recommendation or curating system that we made using content-based clustering. Thank you.